Hi, today we are going to start chapter 6, and the first section deals with graphing linear inequalities in two variables. So essentially, we'll be graphing linear functions that have inequalities in them. So some common symbols is if we have this inequality here, that means greater than. This same one, but with a horizontal line under it, means greater than or equal to. If it's pointed the opposite way, it's less than. If it has a horizontal line under again, it becomes less than or equal to. Now, we graph linear inequalities just as we would graph any graph of form y equals mx plus b with a few small changes. Now, first, just a bit of review. M is our slope. So that's our rise over our run. And our b is our y-intercept. So typically when I go to graph something in form y equals mx plus b, I'll find our y-intercept, plot that, and then use our slope from there to plot the rest of the graph. Now, for small changes we have for graphing if we have inequalities, if we do not have equal to, so if we have less than or greater than, instead of drawing a solid line between our points, we draw a dashed line. That's because a solid line, when graphing inequalities, means that every value under that line is part of our solution. If it's a dashed line, then points along our line are not part of our solution. Now, once we graph it, we will enter a test point from one of the two regions that our graph is now separated into. We'll take that test point, substitute that x value and that y value into our inequality. If it makes our inequality true, so for example, the side we're expecting to be greater is greater than the other side, we will shade the region that the test point came from. If it does not make our inequality true, we will shade the opposite side. Okay, so we'll look at some examples now. So first one, we've got graph y is equal to 2x plus 3. Or sorry, y is greater than 2x plus 3. So right away, we see we have a y-intercept at 3. So I would plot that first. And we have a slope of 2, which that's the same as 2 over 1. So that would be a rise of 2 over a run of 1. So that means we're going up 2 over 1, up 2 over 1, and so on. Alternatively, we could also, to get positive 2 here, we could have negative 2 over negative 1, which would mean we go down 2, left 1, down 2, left 1. Now, because we did not have our equal sign here, it is going to be a dashed line. And now at this point, we will do our test point to figure out which side of our graph do the values of each coordinate satisfy this equation. Now, if it's available, tend to use 0, 0 as my test point because it makes calculations easy. So I'm going to test 0, 0. So we have y is greater than 2x plus 3. So we've got 0 is greater than 2 times 0 plus 3. So we've got 0 is greater than 3. Now, 0 is not greater than 3. So where our test point here is not part of a solution because this did not work. Now, because it was on this side of this dashed line, instead that must mean that points on this side of it are part of our solution. So to show that they're parts of the solution, we will just shade that area in. So therefore, any point in the shaded area, if we were to plug into this equation, will work. So for example, if I went up here to, let's say, 6 comma, or sorry, 0, 6, I'd have 0 is greater than, or sorry, 6 is greater than 0 plus 3, which makes sense. Okay, next graph. We're on a graph y is equal or less than negative 3x plus 1. Okay, so once again, we'll start with our y-intercept of positive 1. We have a slope that's negative 3. So that's negative 3 over 1, which is down 3, right 1. Alternatively, it could also be 3 over negative 1, in which case that means we go up 3, left 1. Now, in this case, we have our equal sign, which means any point along our line is part of our solution, which means we will draw in a straight line. Now I'm going to do my test point at 0, 0 again. So that gives us y is equal or less than negative 3x plus 1, put zeros in. So 0 is equal or greater than negative 3 times 0 plus 1. So we've got 0 is equal or greater than, or sorry, 0 is equal or less than 1. That makes sense. So our test point was here. It worked out. So everything on the same side as our test point will get shaded in. So every point in the shaded region, when substituted into our equation, we'll make it so that what's on the left side of our equation is less than what's on our right side of our equation. Okay, next example, graph y equals negative 1/2 x, or sorry, y is less than negative 1/2 x minus 2. So here's our y-intercept. So we have a y-intercept at negative 2. Here's our slope. So negative 1/2 means we can go down 1 over 2, down 1 over 2, or up 1, left 2. Now, once again, we don't have our equal sign, so that's a dashed line. And we will do our test point at 0, 0 again, because that makes calculations easy. So we've got y is less than negative 1/2 x minus 2. So we've got 0 is less than negative 1/2 times 0 minus 2. So 0 is less than negative 2. Now that does not make sense. Our test point was here, it didn't work out. So we'll shade this side over here. So once again, every point in our shaded region would be considered to be part of our solution.